Well, tubers, I got another project started, but this video is not about this project. It's about this project. So I built this about 10 years ago. This is a power swivel, electric butt driven power swivel and reverse unit. This is probably one of the coolest things I think that I've ever built. It's went through several renditions, but this is its final product. It worked extremely well, but it is at the end of its usable service life. It's rusting away and it's fixing to go to the big scrapyard in the sky, and that project in the shop is what's going to replace this. So this is the clip that the thumbnail came from. I accidentally set this thing on fire welding on it in my shop. It had some oil in the bottom of it. There's going to be some more clips too of this thing in operation at the end if you want to hang out and watch them. So I think I'm going to go over these parts really quickly. I'm going to go talk about what this does and what it's needed for, and then we're going to come back and talk about in detail how it works. And I got some videos, some projects of the past. I got a 671 Detroit generator. This is what makes the power to run all of this. This is a power swivel. This hangs off the bells of the rig. I designed it. It's rated for a load of 100,000 pounds. It is electrically driven, and this is what the tubing screws onto the bottom, and this gives you the ability to turn the tubing. If you put a drill bit or something on the bottom of the tubing, you can essentially use it to drill, and that's what this equipment is. This equipment in its entirety, if you use all of it, is basically the equipment that you need to turn a well service rig into a miniature drilling rig. We got a little FMC triplex and a water tank, and you put water in this tank. You use a triplex. It sucks out of the tank, pumps out through some hoses down the well, and brings the cuttings and fluids back up the well, dumps it back into the tank. There are some settling troughs up here. The crap settles out in those troughs. You can use a shovel to shovel the troughs out, and then the water runs back into the tank and it's recirculated. But what's this equipment used for? Why is it needed? What does it do? Etc. So there's a conglomeration of stuff out there, and I showed you the big parts. You know, we got the power swivel, the tank, the pump, the hoses. There's a lot of other small little pieces, hammer unions, 90s, a lot of different thread changeovers to go to different size threads, different kind of threads. There's changeovers to go from tubing thread to different size drill bit threads to put a drill bit on the bottom of your tubing. There's the Larkin reverse head. That's the seal that seals off between the casing and the tubing. Other stuff. It's just a conglomeration of stuff that is used in conjunction with a well service rig to sort of turn into a miniature drilling rig in ways. Not really, but kind of. It gives you the ability to drill on something in the well. But basically, it's just a set of equipment that is used to clean out a well. All right, let's draw a picture. So I mentioned that this is used often to wash out or to clean out a well. So this is not drawn to scale. This is going to be our casing. We'd have our formation runs right through here. These are like perforations. And then inside here we got our tubing. Our oil comes into the perforations, into the casing, and is pumped up the tubing. This area down here below the formation to the bottom, this is generally, it could be anywhere from just a few feet to maybe 100 feet. If it's a weird situation, it could be more, but this is known as rat hole. Now, when these wells are fracked, you pump sand in here, and as the wells are produced over years, some of this sand can come back. The sand comes and falls in here. You could have frac sand, rust, pipe scale, this general crap, muck, whatever you'll call it, that ends up falling down in here and sort of filling up this rat hole. Now once this gets up to the point that it's like to the bottom of your tubing, or up to the point it's up to your perforations, it can, one, get sucked up in your tubing, stick your pump, cause other problems, or if it gets on up higher than your perforations here, it can actually shut the fluid off. Basically plug them up. This is the most common thing that I did with this reverse unit. Was basically washing this crap out of the bottom of these wells. And so how this works is you've got, and I'll show you more in a minute, but you've got a special head that's not worth explaining in this moment. But basically it seals up here. You pump fluid with your pump, the fluid goes down the casing, makes a U-turn, and comes back up the tubing. And that's why these are called a reverse unit or a reverse circulator, because they're actually reversing the flow, the standard flow, what you would think going down the tubing. And so the tubing, of course, extends up out of the well. It's hooked onto the swivel into a well service rig, and the well service rig slowly adds joints to tubing or lowers it down in the well, and the bottom of the tubing gets down in the sand and the muck, and you sort of vacuum cleaner the crap up. It comes up the tubing and into the settling troughs of the tank out there, and you shovel it, shovel the sand out of it or whatever. This is 90% of what I did with that. But going back to the whole turn it into a miniature drilling rig part of it, there's several situations to where you might actually need to drill on something. We're not just talking about soft sand and stuff you can sort of just spud the pipe through. It's something you've actually got to drill on. I've done quite a few re-entries. It'd be a situation where the well is plugged and for some reason or another the operator wants to unplug it. The thing is full of cement. You take a drill bit and you drill all the way through the cement top to bottom. You could have junk in the hole. If you drop a packer down here or something, you've got to mill through it. They make special mill shoes that are sort of like a big giant hole saw that are 6 feet long or something. You go down there with a hole saw and you'll cut over the packer, cut through the steel of the packer. There's also a thing called a bridge plug. They're set with a wire line. They're just a cast iron chunk with some slips on it and a rubber. It's used to seal off, and it seals off anything down a hole so nothing comes from where you set it up. And sometimes they need to be drilled out. You go down there with a tube and a drill bit, and you'll turn the power swivel with a drill bit and drill it out. All right, so I'm going to jump up on this thing. I'm going to show you what it looks like up there, how it works, how the control panel works, what everything does. I had a couple of really big advantages to this that I plan on sort of moving to my new one. And two of the three big advantages is everything on this trailer that you need is all included, and it's all on the trailer. There's no 2 trips. There's no extra anything. Somebody calls me and says, hey, I need well washed out. I could jump in that truck, swing by and grab me a Gatorade on the way out of town and be anywhere in an hour, where everybody else had to have semis with low boys, everything's skid mounted, the tank's mounted on a skid, the pump's mounted on a skid, the power swivel's mounted on a skid. And I often could leave my house, go do a washout job, and get back home before anybody else around here could even get their equipment to the location. So we'll start out with the power swivel. I'm going to skip over it for now, but it is basically a electrically driven device that can turn the tubing and has a liquid seal so that you can pump fluid down the tubing or back up the tubing under pressure, nothing leaks. We're going to reuse this on the new one, and we're going to spend a lot of time talking about it at a later date. We got a 671 Detroit generator. It's got a few modifications. Of course, it's got a hydraulic governor on it. I have got an idle setting with this, and there is some electronics in this box that allows this generator to idle without actually hurting the generator end. I've got a Gardner-Denver, this is the FMC, I don't remember the model number, 3-inch stroke, 3-inch bore pump. It's rated 1,000 psi, 20 horse motor. Got a control panel over there. I think we ought to probably look at it next. We're looking for wasp nest. Here, Mr. Wasp. Here, Mr. Wasp. I don't actually see any. How'd you not kill somebody? Well, the big thing is that I didn't. So this is the brains of the operation. One of these VFDs runs the power swivel. One runs the pump on the motor. There has been a lot of things changed and moved around. Everything is not like it originally was. Used to have an additional centrifugal in the back. End of the video, I'm going to talk about there's actually a big centrifugal over here. Anyway, this is all pretty straightforward. Here's a plug that runs the pump. This is the plug that actually runs the lights on the trailer. I got power if you need to charge your cell phone. This is a control for the generator. This is power from the generator. So here's a control board for all this. This was the power swivel. This is a power swivel reverse, off and forward. The power swivel speed. This is a reset and a jog button. Like when you go to make your tubing up, you run forward, you can hit this button and turn the tubing slowly, like to tighten it up or whatever. This runs the pump. This initially ran a cement mixer that I used to have, and these have both been disconnected. This is what runs the generator. I don't know if it'll start. Wrong button. Oh, the batteries are low, maybe. Oh, that's upsetting. Anyway, the generator, this is how you started it. It would idle, and you could hit this button that would cause it to rev up. You could cycle the kill switch, and that would make the engine idle. That was nice, instead of having that engine screaming when you didn't need it. So the pump sucks through that homemade filter. This would be relatively full of water. It pumps back through this 2 inches coming up through here, and that is where the water would go to go out to the well. That's your pressure output. This valve here was a relief valve, and you could open this when you started the pump to get the air out of the pump or whatever. We got our pressure gauge. This is the return line. This is some of the crap that came out of the last well we cleaned out. You can see it's just a rusty, sandy, fine stuff. Mostly pipe rust and scale. Probably some sand in the bottom too. Anyway, its connection is down there. Fluid comes back up in here. Made a lap. It started here, went all the way around over that trough, around here, and that's where it goes back down into the tank. Got my stairs. Drop the stairs right there. This control panel was removable. It had this long cord. This was handy if you were running this by yourself or running on your rig. You could unwind this and carry it over to your rig, drive a T-post in the ground, set this on a T-post, and you could run this machine from anywhere. This cord here is a cord that goes to the power swivel. This plugs into the power swivel, and I would just kind of sit here and keep it looped and just have a nice little slack to the power swivel. All right, I actually got the generator to start. It's at idle now. We'll hit this button and it'll go to full speed. I guess I should turn everything off. And I can just cycle the kill switch, any of the kill switches, and that'll cause it to go back to idle. It's got this kill switch, that emergency kill switch. There's actually one up there too. The pump will run. See, I can command with that any speed that I want through this VFD, and I can run the pump at any speed. I can run it really slow. Let's just sing it up there so you can see it. Or I can run it really fast. All right, let's shut this thing down. All right, so in these VFDs, not only can you set your speed, but you can also set up a torque limitation, or a calculated motor power output. And obviously on a pump like this, the power output is equal to the pressure. Okay, I got to kind of tell a story and give some scenarios to sort of give some more advantages, give the reasons why I built a centrifugal. There's a centrifugal sitting out there rusting away. What my idea was behind it. If you hire anybody to come wash a well out for you, if it's a big giant frac truck, if it is someone that's got an acid truck or a cement truck with a big pump on it, or you get an actual reverse unit, one of the problems is that any of those pumps will produce enough pressure, if you deadhead them, to blow something up, to blow a hose up and kill somebody, blow a casing leak in your well. This really cause problems. And so any of those scenarios that you've got one of those guys washing a well out there, is one guy and his only job is to operate that pump. And he's standing there with his hand on the throttle watching the pressure gauge, right, getting ready for if something pressures up or plugs up. He's got to slam that throttle shut or stomp a clutch or do something, because he's got just a split second before something pressures up, explodes, and kills somebody. Well, I don't like this. That's very nerve-wracking to run. And so when I went to build this first reverse unit, one of the things that was a must to me was to circumvent that problem. I wanted to eliminate that issue. And my initial thought was I wanted to build a big giant centrifugal pump and put up 500 pounds that pump basically an unlimited volume of water, as much water as you could push down 2-inch pipe at 500 psi. And obviously with a centrifugal, if you slam a valve shut or plug something up, nothing explodes. It just quits pumping. It just has a maximum pressure. Well, the centrifugal worked excellent. It circulated those wells better than, I mean, much better than that triplex, better than the frac truck, the frac wagon thing we built. By the way, I've washed a couple wells out with that. I don't know if I've already said. They weren't mine, y'all didn't get to see them, but I have used it. But anyway, it worked excellent, but it had an Achilles heel. I couldn't keep bearings in it, so after fighting it about a year, I gave up on it. And so my next step was, as I put that little FMC triplex on there, it would move about 2.7 barrels a minute. It's got a 20 horsepower motor, and with that VFD set basically at its maximum current at 20 horsepower, it'll produce about 500 psi. And this worked really, really good. It wasn't just a scenario where you tag bottom with a tubing, you hit bottom too hard, plugs the tubing up, and like trips a, like a, fault or something. It would just slow down and the pump would stop, and it would just try to roll it forward, and you pick the tubing up, and it would just take back off and go back to running. It worked excellent. And anyway, that's one of the big advantages I had with that reverse unit, is I didn't have to be right there with my total focus being on pump pressure. I could just turn it on and walk away. If something screws up, same with the power swivel. If the power swivel locks up, if the pressure gets too high, it just has VFDs and microprocessors to make those decisions for you. One of the other big advantages that I want to touch on too, that we're going to put back on this, is the power swivel. Somebody calls me and says, hey, I need a well washed out. You drive out there, get to washing the well out, you sit down and hit something hard, you can't spud through it. Well, you've already got the power swivel. All you got to do is plug a cord into it, drag it around there, hook it up, hang it on. I mean, it's kind of a pain. It's heavy. It takes a couple guys to wrestle around on the little cart that it's on. But it's already there. I don't charge any extra for it. And there was a lot of people really like that, because once in a while you get into something hard, and even if you don't have a drill bit on the bottom of the tubing, if you can turn on it continuously and spud, a lot of times you can get through whatever's at the bottom of the well. All right, so let's walk out there and look at that centrifugal. And at the end of this video, I've got some cuts off my phone of videos that I've taken running that reverse unit. I did some little short things. I'd like to cut them in. Maybe y'all can see how it works. All right, so here's the centrifugal. I built this completely from scratch. This is a big heavy piece of tubing. This is where the bearings are. It's got a Timken tapered roller bearing back here. It's got a cylindrical roller straight bearing here, and a thrust bearing up here with a plate. And so this impeller, the fluid comes in on the inside of the impeller. And I did this because it's relatively high pressure, 500 pounds or so. And I didn't want to have to hold 500 pounds of pressure with a packing gland. And so this has got rope packing with a plastic packing gland, stainless and brass nuts. And you tighten those nuts down, and that pushes that rope packing that's in here. It goes in, I can see it in there, I don't remember, it goes in there a ways. You can't really see anything in there. But anyway, fluid comes in here, comes into this impeller, and is slung out by centrifugal force, driven by a 150 horsepower electric motor. That motor is driven off the generator. That's why I ended up with such a large generator to begin with. And then it had a housing that bolted onto there that is right here. And this is all this 1-inch plate. I just built the whole thing. It's all just torched out, welded up. Of course, I had to thread all the bolt holes. It's got a 3-inch output and a drain. I built this impeller at 16-inch. It's 16-inch because that is as large as would fit in my lathe, though actually 16 inches is the size I had determined it needed to be. This 1-inch plate with 1/2-inch little fingers welded on it. The vanes get bigger as they go down in there. There's a step. This is all this 1/2-inch plate that's cut out. I got all this stuff straight and squared up. Had this, this is just torched out. Like I say, it's truly a homemade centrifugal pump. Anyway, the pump worked excellent. It pumped a tremendous amount of fluid. It would actually pump 55-gallon barrel through a 1-inch nipple in 14 seconds at about 500 psi. The disadvantage is I couldn't keep these bearings cool. It kept burning up this thrust. It had a thrust bearing in here. I couldn't keep the thrust bearing. I did all the engineering on it. I thought the loads on this was, I've forgotten, it is a tremendous force pushing in I built this jacket on it. This had water pumped through it at a high rate of speed to keep cold water on the outside of this jacket. This was originally a dipstick. Obviously had a steel housing that went here. This all ran in oil, but I just couldn't keep the bearings together. It would work fine if you ran it for 10 or 15 minute washout job, but if you try to do a reverse unit job, which I did, and run it for an hour or two, it would pretty much smoke the bearings every time after a couple of hours, and so it become a yard ornament. Here's one of the initial tests of this pump. We're pumping a 55-gallon drum. I've actually got this pump running slower here too. It doesn't quite have as much pressure, but you'll see in just a second it pumps this 55-gallon drum out in like 14 seconds or something. Here I am turning the face of the impeller flat. Here I'm drilling probably a bridge plug. It might have been the wiper rubber, but we're drilling up some rubber off something. I think this was just a normal washout job. We was just cleaning the well out, but the well was full of oil, and I shot a video just because it looks cool. Got some roller chunks coming through the bit. You can see the pressure kind of spike is sort of plugged up. It has been running here about 250 pounds or something. It's up to about 400. Hopefully it doesn't plug up. Hopefully it comes loose here in a minute. This was a re-entry. You'll see here in just a second. We're drilling cement. We're using an earth pit and fresh water. This well had, like, I remember it specifically, 1,500 foot or something, solid cement. It took like a week. So here I've been drilling cement. This is with my rig, and I'm just playing around with this to kind of show it off. I turn the torque way down, and when I stack out, put too much weight on the bit, you can just see how the power swivel sort of stops. It keeps trying to rotate, and as soon as you pick some weight up of it, it will restart. And this is a washout job that wasn't needed. The operator thought the well had crap in it. We ran a whole extra joint, didn't tag anything under the perps, and we just sit here and circulate it, wash the oil that was in it out of it, and called it a day. That's all the video. Appreciate you watching. I will have the next one out in the next, it might be next weekend. I'll probably get it out tomorrow about the next project. Appreciate you watching. Catch you on the next one.